Okay, working with the fundamental theorem of algebra. It asks us, fundamental theorem of algebra is going to identify very easily how many roots a polynomial may have. And looking here with this, looking from our notes, if I have this polynomial written in standard form, x to the third minus 3x squared plus x minus 3 equals 0, I should know that, according to the fundamental theorem of algebra, that I'm going to have 3 roots with this polynomial. They may be real, they may be imaginary, but there's going to be 3. So when it asks me to find all the roots, remember the first thing that you want to do when you're looking at factoring is you want to find a greatest common factor. If you don't have one, you might look for factoring by grouping. And that is where I started. So what I saw was I had 4 terms. So I looked at the first 2 and the last 2, and I went ahead and did a little factoring by grouping. And it turns out that, well, out of the first 2, I was able to factor out x squared, leaving behind x minus 3. And when I say factored out, I could take x squared away from this term and x squared away from this term. The next, so if I did factoring by grouping correctly, the next 2 are going to be factored out the exact same thing. So if I were to take x minus 3 out of x minus 3, well, I would have factored it by 1. And x minus 3 divided by x minus 3 is going to give me 1. So when I place these back in their parentheses and I regroup them, I have x minus 3 times x squared plus 1 equals 0. And of course, this is something that we did last week where we learned how to factor the sum of squares using our imaginary number. So using the formula there for that, and I end up with x minus 3 times x plus I times x minus I equals 0. So I made each one of these equal to 0. Did my inverse operations, and there I have x is equal to 3, and then x is equal to negative I or plus I, or x is equal to plus or minus I. And that is how you would find all the possible roots for that equation, for that polynomial. And yes, I originally said there would be 3, and there are 1, 2, 3. Okay, now the next little section in this part looks for you, continuing with the fundamental theorem of algebra. It wants you to find all the roots. And of course, we've talked about roots, zeros, solutions, they're all the same thing. So what I've done is I've gone over here and I've worked out my possible rational roots to see what my possible rational roots are, so I can try to figure out how I'm going to factor this. And I'm going to use division because it's a cubic and it's not perfectly, it doesn't follow one of our formulas, so I need to do what I know how to do. So I'm going to start by factoring out a 1. And of course, here's my setup is going to be coefficients of 2x cubed, x squared. Sorry, I did that wrong, didn't I? Okay, so I did some corrections. I have 2 is the coefficient of x cubed, 1 is the coefficient of x squared, 0 is the coefficient of x because it's not there, and 1 is the constant. So when I do my synthetic division, I add down, multiply across, add down, multiply across, add down, multiply across. Well, this is not, it's not a root because it doesn't zero out. So again, let's see here. Let's try negative 1. And as I do my synthetic division, I add 2 down. 2 times negative 1 is going to be negative 2, negative 2 plus 1 is going to be negative 1. Negative 1 times negative 1 is going to be 1. And of course, 0 plus 1 is 1. And then doing my cross multiplication again, I get negative 1. And then 1 plus negative 1 is going to give me a 0. So yes, negative 1 is going to be one of my roots. That leaves behind 2x squared minus x plus 1. And that is a quadratic, which I think we're going to have to use the quadratic formula to factor, so I know I have A equals B equals C equals. Okay, so what I've done is I've found my A, B, and C for this quadratic equation, and I know that my quadratic equation formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, and I've done some substitution with my values of a, b, and c, and now all I need to do is simplify. So I have x is 1 plus or minus, and I know that all of this stuff in here becomes it's going to become 1 minus 8 all over negative 2, which is going to be 1 plus or minus the square root of 7 over negative 2. So again, I bring 1 plus or minus I square root of 7 over negative 2. Let's see, 2a, I actually messed up a while ago. Hopefully you guys caught it. If you didn't, we'll catch it right now, that I was using the wrong value in the denominator out of habit. So that is 2, 4, 4. Okay, so there you go. It's 1 plus or minus I square root of 7, all of that over 4.